Hello, everyone, and welcome to another episode of Clay Loves Logic. On this channel, I solve logic-based Sudoku puzzles I find interesting. It's Friday, I'm off work, it's a long weekend, and I get to do some puzzles. Today, we're going to be looking at the puzzle Even Cages Even by Daniël Rokven. As always, I'll put the link to this puzzle in the video's description so you can try it if you'd like. With that in mind, let's get into the rules. Normal 9x9 Sudoku rules apply. You have to have the digits 1 to 9 in every 3x3 box, in every row, and in every column. Killer cages. Digits in cages must sum to the number in the top left corner and cages of the cage and cannot repeat. Cages are made up of only even digits. That's interesting. Okay. Non-consecutive. Cells that are orthogonally adjacent cannot contain consecutive digits. Okay, well, let's get started then. And it's going to be interesting because any 20 cage just has to be all the even digits, doesn't it? 8 plus 2 is 10, 4 plus 6 is 10. That's how you get to 20. Okay, well then, if it's even only, that's always 6 and 2. Neither of these are 6 or 2. Neither of these are 4. I feel like this might be a quick one. That is the thought. How do you get to 10? I guess either way works, doesn't it? Yeah, so what about 18? What do you have to cut out to have an 18? Just the 2, right? This is going to be 4, 6, and 8. 6 and 4 is 10. Yeah, and there's already a 6 spoken for, so this is 4, 8, so we get a digit as a 6. Awesome. And now, same thing here, where this has to be 4, 8, 6, but this is not a 6. Okay, a 12. How do you make that? It's going to have to be 2, 4, 6, right? 6, and yeah, and so now this is 8. So none of these are 8. And because remember, these can only be even digits. Well, now this is a 4, 6, 8 triple, so this has to be a 2. It's the only even digit left, which makes this an 8, which makes these a 4 and a 6. And that's going to make this 14 cage a 2. And that's going to just have to go with 8 and 4, right? Yeah. And it's just going to be in this order. It's going to give us a 4 and an 8 and a 6 and a 2 and a 4. And we are going to be absolutely flying through this puzzle, I think. Oh yeah, because this has that's that, so that's an 8. This is a 6. So none of these are 6, and this isn't 8 either. 4, 6, 4. Okay, so now this is 8, isn't it? Because well, we mustn't get carried away. There's 8 spoken for here. But yeah, this doesn't have to be an 8. Careful, Clayton. Just because we're going fast doesn't mean we must be sloppy. One point to note is this has to be a 2, doesn't it? Because both of these cages need a 6, and they'll have to alternate. But what it means is all the 6s are spoken for in these rows. So this is a 2, and that is a 6. That will remove this ability to be a 2. Now we have a 4, 6, 8 triple. 2, 4, 8 triple. Yeah. All right. Well, that's nice. And now we can think about this whole non-consecutive thing, I think. Although maybe we can finish all these cages first. I actually don't know if we can. What do we know about 2s so far? One of these is a 2. What else? Ah, this is a 2 via Sudoku. That's a 2. It's going to be a 2. Okay, that's all the twos. They're penciled in at least. Fours now. Yeah, I'm not sure yet. This is a 6 by Sudoku because there's always a 6 here and there's always a 6 here. So this is a 6. And that is going to tell us not a ton. But it does pencil mark all the 6s. And 8s, I mean, 8's in one of 2 places up top. 8 is in one of these places. 8's in one of these places. And then in this box, it could be anywhere here, I think. Yeah. Yeah. Okay. That's the even digits, and I don't think we can contend with the cages anymore at this point. So let's think about the non-consecutives and start trying to get some odd digits. Now this is not 1, 2, this is not 1, 3, or 5. So this is only from 7 or 9. And this is not 1, 3, or 5. So this is 7, 9. Again, right? It's not, yeah, because 2 is consecutive with both 1 and 3. And 6 is consecutive with 5 and 7, actually. So this is 9. Just like that. And then this is going to be 1, 3, 5. So this is a 5. And this is a 1, 3 pair. And a 1, 3 pair with a, yeah, so this is just 7 or 9. And this is now 1, 3, 5. And this is now 2, 2, 7, and 9. Then in the middle, we'll have 1, 3, 5. Yeah. Okay, great. What do we know about, what else is interesting here? What about this? It's not a 1 or a 3 or a 5 or a 7. This is just a 9, isn't it? That's really interesting. Wow, that's powerful because a 2 is consecutive with 1 and 3, and a 6 is consecutive with 5 and 7. So it's only a 9. Wow. So this will be a single digit too, won't it? This will just be a 5. Won't be able to be a 1, 3, or a 7 or a 9. This is just a 5. Wow, anywhere there's 2 even digits side by side, you can just figure it out. This has to be a 5 too by the same logic. And now, sorry, I need to take this. Let me just pause this. Okay, so now what can we say about this? We need to place, well, actually, let's start up here because we only need 3 digits. We need a 1, 3, and a 9, don't we? And we can't remove anything from that yet, but over here we'll need 1 still, 3 still, and neither of these are 1 or 3, are they? No, that's not true. This one isn't. This could be a 1. So 1, 2, 3, 4, 5, and 7. This couldn't be a 7, nor could this. So we just get a 1 and a 7 and a 3, 9 pair, which gives us a 1 and a 3. Down here, we need 1 and 5. No, 1 and 7. Isn't that right? And it is. And then up here, we're going to need 3 and 9. And we can actually resolve that via the consecutive rule. Okay. And we are just moving and grooving through this puzzle. What about this? This has to be from 1, 7, and 5, does it not? 1, 5, and 7. Yeah. And then this also has to be 1, 3, and 7. So we're going to need to figure out where we place these twos. That's going to be the next really helpful thing. And so with this 2 here, you know, 1 is not here, and 1 is not in this row. So 1 is only in a few places. By the same logic, well, actually, where does 3 go now? So 3's not here. I actually don't know where 3 is yet. I'd like to be able to place a few more of these even digits. They're really, really powerful at solving the puzzle. I just don't think I can just yet, actually. What about these? This is going to be from 3, 9, and 5, is it not? No, 3, 9, and 7. And that's going to be interesting because that's never going to be a 3. This is never going to be a 7. So this is a 7. And now one of these is a 7. One of these is a 5. And then one of these is 3, 9, and that's not 3. Yeah. And this is 1, 3, 5. But if it's 2, it's only 5. That's helpful. And then what is this? 1, 3, 5, 9. Wow, in like any order so far. Let's just keep pencil marking everything and we'll narrow it down here, won't we? Well, so here's a trick. And, you know, we can say that those digits are different. So never mind. I was going to talk absolute nonsense. I can see my train of thought just was just silly, just didn't make any sense. Thought I saw something that I absolutely didn't see. Well, you know what I think? I think this is a 5. I think that's what we're supposed to take away. First of all, this is never a 9. I think this has to be a 5, doesn't it? Because one of these is 4 and one of these is 6, and both of those would be consecutive to 5. Yeah, so that can't be a 5. None of these can be a 5. That just would not work. So 1, 3, 1, 3. Yeah, that's good. How could this be a 6? It can't because of the 7. I don't know when we got that 7. I can't remember, but that does clear up a 2, 6, which is going to give us a 4. Remove those ability to be 4. That's a 2, 8 pair. What else is that telling us? Oh, a 6 means none of these are 5. Oh, a 2 means this isn't 1 or 3. Oh, this 4 now. 6, 4. So 9, 1. Oops. 9, 9, 3, 1, 7. 5, 3, 1, 9, 5. What is this now? 2 or 8 somehow. And then this is 1 or 7. So this is always 3. Okay. There's only a couple digits left here now, and it is just 3 and 7. So this is a 9. So this is a 4. This is an 8. This is a 3. This is a 9. None of these are 9, nor are they 3. So we get a 1 and a 5. And there's a whole bunch for us. Yeah, let's just remove the 5s. Let's remove the 8s. We have a 4, 6 pair. We have a 1, 3, 7. This is a 1, 7, or 9, isn't it? And it's not a 1. This is a 7 or 9. This is a 7 or 9. So this is a 1, 3 pair, which works with a 4, 6 pair that works. Okay. Well, look, this isn't a 3 anymore. This is a 7. Because it would be consecutive with the 4. So that's not a 3, but excitingly, none of those are 7s. Okay. So what shall we appreciate next? Is this a genuine 1, 3 pair? It is, isn't it? So that's a 7. Why can't these be 7s? Yeah, why can't this be a 7? This could be. Why couldn't this be a 7? I almost made a mistake there. In fact, yeah, I mean this could be a 7 too. Okay, gotta be careful there. This isn't a 2 at least. We have 3. We have all the odd digits spoken for. So in fact, this could never be an 8. Or all the even digits, sorry. So this is just 1, 5, 7. Yeah. And this is never a 9. This is a 1, 5, 7 triple. We have 1, 2 even digits. We need one more even digit, one of 2 positions, but all the even digits here are spoken for. So this is an even digit, which forces it to be a 2. Other even digits, odd digits, all make sense. This is now a 5 because it can't be a 1 or a 3, which gives us a 1, 7, 5, which gives us an 8 because it can't be a 4 or a 6, which gives us 4 and a 6. And that gives us a 4, which gives us a 2, which gives us a 6, which gives us an 8. This is no longer 3. Oh, we have a 7, 9 pair that appears to be legitimate. 1, 3, 7, 1, 3, 9, 7, 9. Oh, and then 1, 7, 8, 2. Congrats, you solved the puzzle. 19 minutes, 2 seconds, 2,140 people solved in 188.9 days. I did like that puzzle. That was a fun puzzle. Quick little one to shoot me into the weekend. Daniel Rokven. Great puzzle. I enjoyed it. I hope everyone enjoyed watching it, and I will see you on the next one.